Hey guys, it's me again. Welcome back to my channel, JK. So here we are for lesson 10.1, day 2. So this is our third lesson here in chapter 10. Today we are going back to parabolas, which we focused on in 10.1, day 1. But now we're going to really focus on parts of the parabola and breaking that down. So if you see our objective, it says use vertex form to identify the zeros, the vertex, and the axis of symmetry. So really looking at those parts of a parabola. Here we go. The first part of a parabola that we really want to focus on is the vertex. And the vertex is the lowest or the highest point on the parabola. So notice here in this parabola, my vertex is right there. And here in this upside down parabola, my vertex is right there. So in this example, this is my lowest point, which we've talked about before. We call this a minimum because it is the lowest point. Whereas in my other parabola, the vertex is the highest point, so we call that a maximum. All right? The next part of the parabola that we're going to focus on is the axis of symmetry. Now, the axis of symmetry is a line through the vertex, but we could just as easily say that it's an invisible line. Here in our graph, you see that it is a dotted line. Okay, and so this is an invisible line. If you graph a parabola on your calculator, you will not see that axis of symmetry. It is something that we have to draw in ourselves. The axis of symmetry cuts the parabola in half. Okay, when things are symmetrical, like your face, it is symmetrical because you have an eye on the left, an eye on the right, an ear on the left, an ear on the right. So the axis of symmetry is cutting that parabola in half. And the axis of symmetry is always written in the form x equals. Now here in that blank, we would put a number. So for example, x equals 3. You could have x equals -1, x equals 15. So the reason that it's x equals is because notice that my axis of symmetry is crossing the x-axis. Because it's a vertical line and it's crossing the x-axis, that's why the axis of symmetry is always in the form x equals and then just the number. Here is where it crosses that x-axis. The next part of the parabola that we are going to look at are the zeros. Okay? And a zero is where the graph crosses the x-axis. All right? So that's what a zero is. It's where the graph crosses this x-axis. So you notice here in this example for the parabola, we have a 0 here at 3, 0, and we have a 0 here at -1, 0. And look at my axis of symmetry. Okay, if I notice here, my axis of symmetry is right in between those zeros, perfectly halfway through. I go 2 units to the right, and I'm at 1, 0, and I go 2 units to the left, and I'm at another 0. So I have zeros on the 2 extremes of the x-axis, and my axis of symmetry right in the middle. And notice my axis of symmetry also goes right through that vertex. Which brings us to vertex form. So vertex form might look a little complicated. This is what we consider vertex form. Y equals a, parentheses x minus h squared plus k. But it gives us a lot of really useful information about the parabola. So these letters, a, h, and k, all represent numbers. So an example of an actual equation in vertex form would be something like, let me create some space here. An actual equation in vertex form could be something like y equals 2x plus 3 squared minus 6. Okay? So there's an example of an actual equation in vertex form. Now, the vertex of the parabola always comes from the letters h and k. Now notice, we talked about this a little bit in 10.1, day 1. H is always going to be the opposite. Whenever we're in parentheses, we're dealing with the opposite. So if I have In my example, x plus 3, I am actually going to be using negative 3, taking that opposite. However, on the outside, my k stays the same. So my vertex in this example would be negative 3, comma, negative 6. Again, that is a point on a coordinate grid. The axis of symmetry comes from x equals h. So in this example, for my h, I have plus 3. So I would take the opposite of that, and my axis of symmetry would be x equals negative 3. Notice my axis of symmetry is the same as that first number in my vertex. Now, a positive a tells me that the parabola opens up. So if the parabola opens up, it looks like this. You see that it's kind of pointing up. A negative a tells me that the parabola opens down. So it would look like this. And this is where some of your reasoning skills come into play. If my parabola opens up, do I have a minimum or a maximum? My vertex would be here. Is it the minimum or the maximum? And that would be the minimum. So if I have a positive a, my parabola opens up and I have a minimum. If I have a negative a, my parabola opens down, and notice in this scenario, my vertex would be the maximum. Okay, so this is where vertex form really does give us a lot of great information about that parabola. Let's apply all of this, guys, to our example here. So example 1a, identify the vertex and the axis of symmetry. Is the vertex the minimum or the maximum? Double check by graphing. And just a reminder, here you have vertex form again in its original state. So if you're just asked to identify these things, you don't have to do any algebra. You just need to look at this equation and let me know what's going on. So vertex comes from h and k. Remember, h is here on the inside, k is here on the outside. But for h, guys, this is what everyone always forgets. H is always the opposite. So my vertex is going to be positive 3. My k stays the same. So positive 3, negative 8. There is my vertex. Okay? My axis of symmetry is x equals positive 3. Again, because we're taking the opposite of what we have in parentheses. My a, what do I have here for a? The number that I have is a 2. So 2 is a positive number. So I'm not even going to worry about a negative a because I don't have one. So if it is a positive a, that means I open up. So that means my vertex is going to be a minimum. Now to check this by graphing, remember we can go into our graphing calculator. We can go into y equals, and you can put this entire equation into your calculator. And you can confirm that the vertex is at 3, negative 8, that you have an axis of symmetry there, and that it opens up because it's a positive a. Now for example 1b, we have a new equation, but we need to identify those same things, the vertex, the axis of symmetry, and telling me if the parabola opens up or down. So for h and k, notice here is my h, here is my k. For h, please remember that we always take the opposite, and for k, it stays the same. So the opposite of 3 is going to be negative 3, and then I just keep my 4. So there is my vertex. The axis of symmetry is x equals h. Always take the opposite. So x equals negative 3. And remember, those two numbers should match up. My axis of symmetry should be the same as the first number in my vertex. Now, let's find out what a is. A is this number out in front. It's just a negative. So remember, that is representing an invisible negative 1. So if a is negative 1, I can ignore this positive a because my a is negative 1. So that means my parabola opens down. And if my parabola opens down, that means my vertex is here, and that would make my vertex a maximum. Okay, guys? So notice we're not doing any algebraic work. We're just understanding what vertex form is telling us about this parabola. Now let's talk about sketching the graph, and you are going to have to sketch a graph for me in your homework. To sketch the graph, you're going to need two things. You're going to need to know the zeros of this parabola and the vertex. To find the zeros, what we do in order to find the zeros, the first step is we replace y, or f of x, with 0. Then we solve for x. There are going to be two answers, and those are going to be the zeros. And then keep in mind, this goes back to the lesson that we did yesterday. When you take the square root, there are always two answers. The square root of 9 is 3 and -3. So that's how we're going to end up with two answers. And here we go with our first example. Find the vertex and the zeros, then sketch a graph of this function. To find the vertex, all we have to do is look at the equation. Remember, my vertex comes from h and k, where h is the opposite and k stays the same. So that means my vertex is going to be +2 and +5. So there's my vertex. Now to find the zeros. Remember from the last slide, step 1 is to replace that y with the number 0. So I'm going to go ahead and instead of y, I'm going to write 0. Everything else stays the same, -3, x minus 2 squared plus 5. And now I'm going to solve. So the first thing I'm going to do, see if there's anything I can add or subtract. I can subtract that 5 from both sides. And so now I have -5 equals -3 x minus 2 squared. So now that I've added or subtracted, let's see if there's anything that I can multiply or divide. Remember, there's an invisible multiplication here, so the opposite of multiplication is division. So I go ahead and divide both sides by -3, and now I have +5/3 equals x minus 2 squared. Okay? My next step, because remember, this x minus 2 is glued together by those parentheses, so my next step is going to be to get rid of this square. And how do I get rid of that square? By square rooting. So I square root both sides. Over here on the right, my square root and my square cancels out. And then when I take 5/3 in my calculator, because I don't expect you to know this from memory, of course, so I'll do 5/3 and then I'll take the square root of that, and I end up with 1.29. So 1.29 equals x minus 2. Now remember, this is where a lot of us might forget, and we don't want to do that. My square root of 5/3 is 1.29. But what is my other square root of 5/3? My other square root of 5/3 is -1.29. Okay, guys, so I want to have 1.29 equals x minus 2 and -1.29 equals x minus 2. So I have now set up two equations. From there, I'm just going to solve both of them. Add 2, add 2. And so if I have -1.29 plus 2, I end up with x equals 0.709. I'm going to go to the thousandth so that I can have that extra detail. Over here, I add 2, and I end up with x equals 3.29. Okay? So now I have my vertex in 2, 5, and I have my zeros. So now that we have the vertex and the zeros, let's go ahead and graph this parabola. So my vertex at 2, 5, remember the 2 represents the x-coordinate, the 5 represents the y. So here on my x-axis, I'm going to go to 2, then I'm going to go up 5. So here is my vertex at 2, 5. And let me put that here, 2, 5. Now remember, my zeros are where I cross the x-axis. So if x equals 3.29, on my x-axis, I'm going to go to 3.29, which would be right around here, right? This would be x equals 3.29. Now my other 0 up in the top left is x equals 0.709. So 0.709 is going to be right around here. So there I'm going to put x equals 0.709. So what do you notice if I connect my vertex to my zeros? My parabola is actually opening down, so it's upside down, okay? And make sure that we put those arrows there at the end of the parabola. The arrows means that the parabola keeps going, all right? And there is our lesson for 10-1 day 2. Our homework, remember, here are the steps to find it. You go into Google Classroom, into your Algebra 1 class, go to the classwork tab. If you're on a traditional computer or laptop, it's at the top. If you're on an iPad or your phone, it may be at the bottom. And then just go to Chapter 10 homework and you will see it. It will look like this. It is 2 pages, so make sure you do both pages. All right, notice it's nothing too intense. The first couple of problems you just need to identify, and then for the last 4, you do need to do a little bit of work to find those zeros. So let me know, guys, if you have any questions. Put those questions again in Google Classroom and I will answer them, whether that's just typing an answer, I'll put a picture of the work, I'll answer with a video response if that's appropriate. But put all your questions in Google Classroom so that my answer can not only help you, but help your classmates. And thank you guys so much for joining us for this 3rd lesson, and I will see you tomorrow for our next one.